welcome back to the third and final video in this series on weather of Earth's atmosphere. In the last video, we talked about weather fronts and the mid-latitude cyclone. Now we highlighted that the open stage, or the third stage of the mid-latitude cyclone, was very important and that we would come back to it. Well, today's the day we come back to it. Now, what's so unique about the open stage of the mid-latitude cyclone? A lot of weather and a lot of weather patterns can be predicted by using the open stage of the mid-latitude cyclone. So today, we're going to dissect that open stage of the mid-latitude cyclone. And this dissecting is called the geography of the mid-latitude cyclone. Now let's dissect our first section here. This first section exists right above the warm front, and we're going to label it Section A. Now, Section A of the geography of the mid-latitude cyclone contains cool temperature. And why does it contain cool temperature? Because the warm front has not moved through the area yet. The clouds of this region are going to consist of many different types. There's going to be cirrus clouds, cumulus clouds, cirrostratus clouds, altostratus, and stratus clouds. Now, let's move on to the precipitation category. Now, the precipitation can be in the form of rain, snow, sleet, anything that deals with precipitation. And in this region, Region A, precipitation is possible. Now, the intensity and duration of this region's rain would be light and long. And this would be in the form of pop-up showers and other sporadic showers that may occur throughout the day. This also is a drizzling rain if it does occur. Now the pressure of this system is falling. And why is it falling? Because the low pressure system that's connected to the open stage of the mid-latitude cyclone here is getting closer to Section A. So I'm going to represent this falling of pressure by a down arrow. Now, Section B of the geography of the mid-latitude cyclone is right on the warm front. So we're going to draw our section here. And this is Section B, okay? So I'm going to label that Section B. Now the cloud, or the temperature of Section B is warm. And that's because the warm front is moving through Section B of the geography of the mid-latitude cyclone. Now, the clouds that are present at this section of the geography of the mid-latitude cyclone is stratus and nimbostratus clouds. The precipitation here is very likely, and the duration of this precipitation is going to be light and long. So that drizzling shower, you know, when it rains all day, that's probably the type of rain that you're going to experience here in Section B. Now the pressure is continuing to falling because you have that low pressure system moving closer to this section. That takes care of the first two sections. There's 4 more to go, so hang in there. All right, so Section C is when the warm front has moved past an area. And it's a pretty big region here. It consists all of this, all right? That's section C. Okay, so I'm going to label it here, section C. Now the temperature of section C is warm because the warm front has moved through the area. Now the clouds of this area consist of cumulus clouds, cirrus clouds, and clear conditions, or no clouds are present. In the precipitation, there's likely not going to be any precipitation in this region. So that means for the next section, you don't have to worry about it. Now the pressure of this system is continuing to fall, but it's becoming steady as the low pressure has moved past it. All right, so the next section is a section right before the cold front, and it's section D, located right here. Okay, so section D has temperatures that are still warm. Remember, the cold front hasn't moved through yet, so we don't have cold temperatures. We have a warm front. Okay? And the clouds here are cumulonimbus. Now, these clouds are the big thunderstorm producing clouds. All right? So, cumulonimbus clouds are the cloud type that's present here. Cumulonimbus cloud. The precipitation that is going to occur here is likely, okay? So it's likely, and it's likely that it's going to be heavy shore precipitation. This is because it's producing those thunderstorm-like conditions, all right? So the pressure here is still steady, but it's continuing to rise because back here, we have a high pressure system that's moving through region D. So you're going to get steady rising conditions, and it's not rising very much here. Okay, so we got 4 sections of the mid-latitude cyclone down, and we got 2 sections of the geography of the mid-latitude cyclone to go. Now, the next section of the geography of the mid-latitude cyclone is section E. Section E is when the cold front starts to pass through the area. And because the cold front is starting to pass through the area, the temperature is beginning to cool. So it is cooling temperature. Now the clouds of this are cumulonimbus and cumulus. So, and cumulus, okay? The precipitation for this area is possible, and if it does rain, it's going to be heavy and short. So precipitation is possible, and the intensity and duration, if it does rain, is heavy and short. Now the pressure of this system is now going to rise. Now that high pressure system is beginning to get closer and closer to your region. So I'm going to put an upward arrow for rising pressure. The last region is region F, where the open stage has fully moved past an area. So here is region F. Okay, so I'm going to label this region F down here. And the temperature of region F is cold. The cold front has passed through, if that makes sense. Cold front passes through, brings cold temperatures. Now the cloud types here, you're most likely going to see clear conditions, but if there are clouds, they're going to be cumulus, or cirrus. Now, the precipitation is probably not going to happen after a cold front moves through an area. So I'm going to put none down here, and that means we don't have to worry about this category. Now, the pressure is continuing to rise. All right, so I'm going to put an upward arrow for rising pressure. Now, that is the geography of the mid-latitude cyclone. So now we get to the fun part and being able to predict weather. You look at this and you say, so what? Why does this matter? Well, let's say that you get a daily weather map and you open it up and you see that your town or area is located right here. All right, this dot. I'm going to call this town X. Okay, so now you can go to your geography of your mid-latitude cyclone chart and you can say region C. Well, the warm front's moved through, we got warm temperatures, and it's probably going to have cumulus or cirrus clouds, if any, present, and there might be clear conditions. There's probably not going to be a whole lot of precipitation, and the pressure is going to be falling but fairly steady, okay? So you can place yourself anywhere in these regions and be able to predict that weather for that area. Now, what if the geography of the mid-latitude cyclone isn't laid out like this? What if there's not an open state of the MLC here? Well, you can think back, you can use your prior knowledge of what you've already learned about fronts and everything else to determine what your weather is going to be. So, for example, let's say that you just open up your weather map and you see that there's a cold front. Well, you don't see a warm front, you don't see anything else attached to it, it's just a cold front that moves through the area. Well, you can infer from your knowledge that you've gained that there's probably going to be cooler than normal temperatures, there's probably going to be clear skies, and the pressure is probably going to be rising. So you have to put all this knowledge together to be able to predict the weather. That concludes the geography of the mid-latitude cyclone and predicting the weather. I hope you have enjoyed this video series on weather of Earth's atmosphere.